So classwork begins with finding the GCF of the listed terms. So for the first problem, part A, we have 14y cubed and 21y squared. We're going to start with the numbers and break them down using prime factorization. 14 is really 7 times 2. 7 and 2, I can't break down any further. There's no two numbers that multiply to 7 other than 7 and 1. And there's no two numbers that multiply to 2 other than 2 and 1. So this is the prime factorization of 14. For 21, it's 7 times 3. Again, I can't break those down any further. When I look at the two lists, I see the number they have in common is 7. So I'm going to find as the greatest common factor 7, and then I need to know what variable goes with it. If you see it the same way as factors of the variable, this is really y to the third, so y times y times y, and this is really y to the second, so y times y. The overlapping factor is y times y. There's one extra one left here, but the one that I can pull out of both is 2 y's or y to the second. Instead of writing these out, what you can really do is look at the terms and say, what's the lowest power of the variable that I see? Whatever the lowest power of each variable is, that's what should be included in the greatest common factor. So when I look at the next problem, here I have x to the fourth, here I have x to the seventh. The lowest power of the variable is x to the fourth, so that's what's going to be in my greatest common factor. When I break down 3, there's no way to break it down further. It's just 3 times 1, so the prime factorization of 3 is just 3. For 15, I can write it as 3 times 5. Here the overlap is 3. That's why the greatest common factor has 3 as its coefficient. So my final answer for greatest common factor is 3x to the fourth. When I go to factor the expressions in number 2, I'm doing the same general idea. I'm trying to see what's the biggest number I can pull out of each thing. Then I'm dividing it, each of the terms by that expression, and showing what the leftover is in parentheses with what I factored out outside the parentheses. So let's see how that works. 6x and 12, if I factor 6, I get 2 and 3. If I factor 12, there's two different ways I can look at it. I can either look at it as 6 times 2 or 4 times 3. If I do it as 4 times 3, the 4 would break down into 2 times 2. If I'd done it as 6 times 2, the 6 would break down into 2 times 3. Either way that I do it, I end up with 2 times 2 times 3. 2 times 3 and 2 times 2 times 3, well, the common factors that I can take out are 2 times 3 that appears in both of them. So I can pull out a 6, 2 times 3. It's absolutely fine if you looked at 6x and plus 12 and you said, well, I know the biggest thing that goes into both of those is 6. Hopefully, if you're good with your times tables, things like that jump out at you. You do not have to do this prime factorization method. I'm just showing that method if it's confusing to you where I'm getting that number that's the largest thing that goes into both. But to be honest, I'll probably drop the prime factorization as I go along and just kind of jump to what the largest number is. Always know that you could do it this way. When I look for the smallest power of x, I only see one x here. There's no x's here. So the smallest power is really none at all. That's why all I'm going to be factoring out is the 6. I can then write parentheses and say the first thing used to be 6x. It's now 6x divided by 6. The second thing used to be positive 12. It's now positive 12 divided by 6. So next line down, this 6 is still outside. 6x divided by 6 just leaves me with x. Positive 12 divided by 6 leaves me with positive 2. So the factored form of 6x plus 12 should be 6 parentheses x plus 2. When I look at 4y and negative 20, 4 is the largest number that goes into both of them. Again, I can get there by showing 2 times 2. 4 times 5, which becomes 2 times 2 times 5. 2 and 2 is here, 2 and 2 is here. That's how I get to that 4. Y here, but no power y there, so 4 is as far as I can go. If I then take 4y and divide it by the 4, minus 20 divided by the 4, I wind up with the final factored form of 4 times y minus 5. Part C, 64 minus 8x. 8 goes into both of these. Really, if I broke down 64, I'd see it was 8 times 8, which becomes 4 times 2, 4 times 2, and the 4's become 2 times 2, 2 times 2. So really 64 is 2 times 2 times 2 times 2 times 2 times 2 as a prime factorization. 8 breaks down into 4 and 2, 2 and 2. So 2 times 2 times 2 is the prime factorization. I have 3 2's here, I have 6 2's here, so I can use 3 of them when I'm creating my greatest common factor. If I use 3 of them, 2 times 2 gives me 4, times 2 more gives me 8. So I'm factoring out an 8 from both terms. Again, only one of them has an x, so I can't factor a variable out because the lowest power of x is really no x's. If I do 64 divided by 8 minus 8x divided by 8, this becomes 64 divided by 8 is 8. 8x divided by 8 is just x. So I get a final answer, 8 times 8 minus x. For this problem, the coefficients are understood ones, so I can't take that coefficient out. Really, the coefficients just have to stay here. There's no greatest common factor. I look for the lowest power of x that I see. Third is the lowest power of x that I see. So I'm going to factor out that third. I'm going to take what was before and divide by what I'm factoring out. So the x to the third stays out front. This x to the fifth over x to the third by our exponent rules becomes x to the 5 minus 3. That's why it just becomes x squared. X to the third divided by x to the third is just 1. So here I get x squared minus 1. Final answer, x to the third parentheses x squared minus 1. For part E here, 36 and 12, the largest thing that goes into both of those is 12. I then want to write the lowest power of each variable that I see. For x's, I have x squared and x to the third, so the lowest I see is x squared. For y's, I have y to the fourth and y to the third, so the lowest I see is y to the third. So it's going to be this times something. Specifically, when I take 12x squared y to the third out, what's left behind is 36x squared y to the fourth divided by 12x squared y to the third plus 12x to the third y to the third divided by 12x squared y to the third. So the 12x squared y to the third is outside. Here, 36 divided by 12 gives me 3. X squared and x squared go away. Y to the fourth over y to the third is y to the 4 minus 3, which just leaves me with y to the first. When I do this division, 12 and 12 go away, y to the third and y to the third go away, so I'm just left with x third over x squared. X to the 3 minus 2 is just x to the first, so all it leaves behind is a positive x. The correct final factored form of this original problem is 12x squared y to the third, parentheses 3y plus x. For part F here, I start out with 9x squared y squared minus 15xy. When I look at the common factors of 9 and 15, the largest common factor is 3, which is what I'm going to take out front. Here I have an x squared, here I have a y squared. Here I have an x to the first, here I have a y to the first. So the lowest power I see of each variable is an x to the first and a y to the first. I'm then going to be taking 9x squared y squared, dividing it by 3xy, and negative 15xy divided by 3xy. That means I have the 3xy out front. 9 divided by 3 leaves me with 3. X squared divided by x is x to the 2 minus 1, or just x to the first. Y squared over y is y to the 2 minus 1, or just y to the first. When I divide 15 by 3, or really negative 15 by 3, I get negative 5. This x and this x cancel each other, this y and this y cancel each other. So my final factored form is 3xy, parentheses 3xy minus 5. When we factor out from 3 terms, we still use the same general idea. Basically, we're looking for what goes into all 3 evenly. So 10, 30, and negative 20. 10 is the common factor that goes into all of these evenly. So I could take out 10. After I take out that 10, I look at the variables. I've got a y here, I've got a z here, but there's no variable that's in all 3 terms. So 10 is the only thing that I can take out, which means left behind is 10 divided by 10 plus 30y divided by 10 minus 20z divided by 10. So that means this becomes 10 parentheses. When I do 10 divided by 10, I get 1. 30y divided by 10 gives me 3y. And negative 20z divided by 10 gives me negative 2z. So my final factored form is 10 parentheses 1 plus 3y minus 2z. For h, I start out with 8x cubed plus 12x squared minus 4x. The largest thing that goes into all 3 numbers is 4. So I factor out that 4, then I look at the exponents on the different variables. I see the lowest exponent is this, x to the first, so I can factor out x to the first. That means I take what used to be there, 8x to the third, and I divide it by 4x. 12x squared divided by 4x minus 4x divided by 4x. That gives me the final factored form of 4x. 8x cubed divided by 4x, 8 divided by 4 gives me 2. X to the 3 minus 1 is x squared. 12x squared over 4x, 12 divided by 4 gives me a positive 3. 2 minus 1 gives me x to the first. Finally, negative 4x divided by 4x just leaves me with a negative 1. So my final factored form is 4x parentheses 2x squared plus 3x minus 1. In problem 3, it just tells me to factor a negative 1 out of the expressions. Factoring a negative 1 out of something just means write negative 1 outside the parentheses and change every sign inside the parentheses. So here I'm going to write negative 1 outside. What used to be a negative a becomes a positive a. What used to be a positive b becomes a negative b. So again, I'm just writing a negative 1 outside the parentheses is what I factored out, and changing the sign of each of the original terms. Same idea here, write a negative 1 outside. What used to be a negative x is now a positive x. What used to be a negative 8y is now a positive 8y. Factoring a negative 1 out just means changing each sign in the expression. When I factor by grouping in these first 2 problems, they've done the hard work for me. They've already determined what makes 2 parentheses the same afterwards. So all I have to do is say outsides times insides. In other words, x plus 3, the thing on the outside, times x minus 2, the repeated inside factor. Here, t plus 5 is the outside. S plus 7 is the repeated inside factor. Apologies that my t's and 5s look similar to my 6's and b's. Normally when I'm in class, I tell you, please ask me if you're not sure on which one I'm doing ever, or I apologize for my handwriting. That said, this is an S, this is an S, this is a 5. This is a 5, this is an S. Parts C and D require me to do the first part of factoring by grouping, which is to put the first 2 terms together and find the greatest common factor, put the last 2 terms together and find the greatest common factor. So these first 2 terms, 3x plus 3y, the greatest common factor is 3. If I factor out that 3, 3x divided by 3 is just x, plus 3y divided by 3 is just plus y. When I look at negative ax and negative ay, I might be able to see that the a comes out, and if I did that, I'd be left with negative x minus y, but it wouldn't match what I have here, x plus y. So the better thing to do is to take out a negative a. If I take out a negative ax divided by negative a leaves me with positive x. Negative ay divided by negative a leaves me with positive y. I now have the same second parentheses, which means I can apply what I did above and just say outside I have 3 minus a. Inside repeated is x plus y. Again, if I had not seen this negative, I would have wound up with negative x minus y. I would have seen the two parentheses are not the same and said to myself, something went wrong. What can I do to make these parentheses the same? Hopefully I would recognize that it was the negative that I could bring out that would make it work. In part D, I have 9xy and 9xz. A 9x can come out of each of these. 9xy divided by 9x is just y, plus 9xz divided by 9x is just plus z. When I have plus 4y and plus 4z, plus 4 can come out of each of them. Again, it leaves me with y plus z. Since I have the same second parentheses, I can organize this as 9x plus 4, the outsides, times that repeated parentheses, y plus z.